Okay, you're going to have a little bit of a look here at quadratics using this little applet here from Maths OpenRef. And so we're talking about quadratics. They're all in the form, their general form, the way we can write them is y equals ax squared plus bx plus c. And in this little applet, you can just muck around with what happens when you change the values of these a, b, and c, how the graph actually changes. So I'll just quickly, if I make a, I'll just pull it down because I can go, I'll try and get it to 0. There she goes, that equals 0. And I can get it from 10 to minus 10. There you've just got, that's a straight line. You've just got y equals 3x take 8. Okay, so that's what we say in the general form. Y equals ax squared plus bx plus c, where a, b, and c are real numbers and a must be not equal to 0. Because if it's equal to 0, you just get a straight line. So we can see if a is positive, okay, we get a smiley face parabola, and I'll bring it down here. A is now negative, and you get this negative size shaped parabola. Okay, so let's make this positive, and we'll just see what changing these other ones. And this is a little bit more complex. If I change b, you can see it actually sort of quite complicated what it does to the function, sort of moving around here. It's not that important to know, it's just getting a bit of an idea of it. And here, what we change c, we see that's a bit more obvious. It's just moving it up and down. And if I get it to there, there's c is just about 0, get it to there's 0. And if I get them, try and make this 1, just down a little bit more. There you go. And I'll make b 0. Whoops. Come on, there's b 0. There we've just got y equals x squared. That's our normal stock standard parabola. And you see if I move this, it's just going to make it up or make it go down. Okay, I'll just leave it there for a tick. We'll just pause it and we'll come back and we'll look at the vertex form. Okay, so this is another form of how we can write quadratic equations, and it's written in the form of y equals a time with bracket x take h all squared plus k, and we call this, the other one ax squared plus bx plus c was called the general form. This is called the vertex form, and the reason being is because when you get it in this form, you can read off exactly what this point here is, what the vertex is, and it's actually just the point h, k, where x equals h and y equals k. So if you watch what I do here, if I change the value of h, you'll see what happens. The parabola just translates horizontally like that. If I change k, it just goes up and down. And if I change a, it just becomes really, really skinny and narrow. Or if I go negative, it goes into the frowny face. So just showing you, what a little bit about the parabola. So if I just want to make pretty stock standard one, I'll make a equals 1. Just try and bring that down a little bit. Can't quite get it. Bugger it. There you go. Here's 1. I'll just make h equals something easy, like I'll make h1. A half will do. And k, I'll just make k equal to something easy, like, see if I can get it to minus 10. No. Imagine that's minus 10 anyway. So the things we see in this parabola, actually no, I'll move this over here in the end. Okay, we'll do it from there. So this parabola, there are the zeros of this parabola, of this quadratic. There is the y-intercept, there's the vertex down here, and the line running down here is called the axis of symmetry because the graph is symmetrical on each side. Okay, that's just a little introduction to what the graph of quadratics looks like in those two different forms and just how it varies. Okay.